There are places in the universe that look beautiful from far away. Calm, silent, almost peaceful. But that calm is an illusion, because scattered across the cosmos are environments so extreme that survival is not just unlikely. It is impossible. Today, we are traveling through the most dangerous places known to science. Each one pushes physics to its limits. Each one shows what happens when nature stops playing safe. And we begin somewhere familiar. A planet that looks like Earth's twin, but behaves like a nightmare. Number 11, Venus, Earth's evil twin. At first glance, Venus does not seem terrifying. Similar size, similar gravity, similar rocky surface. But step onto Venus and the illusion ends instantly. The heat alone is enough to destroy you. Surface temperatures reach around 475 degrees Celsius, hot enough to melt lead. It is actually hotter than Mercury, despite being farther from the sun. The reason is a runaway greenhouse effect. Thick carbon dioxide traps heat like a sealed oven that never cools down. Then comes the pressure. Venus's atmosphere is so dense it would feel like standing nearly a kilometer underwater. Your body would be crushed long before the heat finished the job. And above you, clouds of sulfuric acid drift endlessly. Acid rain forms constantly, though it evaporates before reaching the surface. The sky itself is corrosive. Spacecraft that land there rarely survive more than a couple of hours. Venus is not just hostile. It is a warning of how a world can spiral out of control. But heat is only one form of danger, because our next destination never stops exploding. Number 10, Io, the moon that never rests. Orbiting Jupiter is a small moon that looks like a science experiment gone wrong. Io is the most volcanically active object in the solar system. Hundreds of volcanoes erupt constantly, reshaping the entire surface. Lava fountains blast hundreds of kilometers into space. Entire landscapes are covered in sulfur, ash, and molten rock. The reason is gravity. Jupiter's massive pull stretches Io like a stress ball, while neighboring moons tug in different directions. That constant squeezing generates enormous heat inside the moon. Io is literally being cooked by gravity. And if the volcanoes were not enough, Jupiter surrounds the moon with lethal radiation. A human standing there would receive a deadly dose within minutes. Io is chaos made visible, a world that cannot cool down, cannot stabilize, and never stops changing. But what happens when matter itself is crushed beyond recognition? We leave planets behind and move into the remains of dead stars. Number 9, neutron stars, cities made of star. Matter, when massive stars die, they do not always explode into black holes. Sometimes they collapse into something almost as extreme, neutron stars. Imagine compressing the mass of the sun into a sphere the size of a city. The result is density beyond comprehension. A single teaspoon of neutron star material would weigh billions of tons. Gravity near the surface is overwhelming. If you fell toward one, your body would stretch into a thin strand before impact, a process scientists call spaghettification. But density is only part of the story. Neutron stars spin incredibly fast. Some rotate hundreds of times per second, firing beams of radiation like cosmic lighthouses. These are pulsars, clocks more precise than anything built on Earth. Small, heavy, violent, and yet even neutron stars can become more extreme. Number 8, magnetars, magnetic nightmares. A magnetar is what happens when a neutron star becomes unstable and its magnetic field explodes in strength. These are the strongest magnets in the universe. Their fields are trillions of times stronger than Earth's. At close range, a magnetar would not just kill you, it would dismantle you at the atomic level. Molecular bonds would break apart. Chemistry itself would fail. Magnetars also release sudden bursts of energy powerful enough to affect Earth from across the galaxy. One flare briefly disrupted satellites despite being tens of thousands of light years away. They are rare, unpredictable, and terrifying. But magnetism is nothing compared to gravity at its absolute limit. Number 7, black holes, where escape ends. Black holes form when gravity wins completely. Mass collapses inward until it creates a boundary called the event horizon, the point where escape becomes impossible. Not even light can leave. Cross that line and information is effectively erased from the universe. Time behaves differently near black holes. From your perspective, the outside universe speeds up. Entire futures unfold while you fall. Meanwhile, gravity stretches you into an ever-thinning strand until you reach the singularity, a region where physics stops providing clear answers. Some black holes are small. Others sit at the centers of galaxies weighing millions or billions of suns. And sometimes, instead of hiding in darkness, they become the brightest things in existence. Number 6. Quasars, black holes that glow. A quasar is not a different object. It is a black hole feeding aggressively. Matter spirals inward, forming a superheated disk that radiates unimaginable energy. Jets of particles blast outward across intergalactic distances. For brief periods, a single quasar can outshine an entire galaxy. If one replaced our Sun, Earth would not burn. It would vanish instantly. Quasars help astronomers map the early universe, acting like distant beacons. But they also show how destructive gravity can become when fueled continuously. And living near one would mean living inside a storm of radiation. But even quasars are only pieces of something larger, the chaotic heart of galaxies themselves. Number 5. The galactic core, cosmic traffic jam. At the center of galaxies, space becomes crowded and dangerous. Stars orbit at extreme speeds. Radiation floods the region. Supernovae occur more frequently. Gravity pulls from every direction. At the center of our Milky Way sits Sagittarius A star, a supermassive black hole with millions of solar masses. Nearby stars whip around it like race cars, their paths constantly shifting under gravitational stress. The sky near the galactic core would be brilliant, packed with stars, but that beauty hides constant danger. High-energy particles, intense radiation, and unstable orbits make long-term survival unlikely. We exist in the galaxy's quieter suburbs, and that distance may be the reason we are here at all. Because some cosmic events do not unfold slowly, they arrive instantly. Number 4. Gamma-ray bursts, instant destruction. Gamma-ray bursts are the most powerful explosions ever observed. They occur when massive stars collapse or neutron stars collide. The result is a focused beam of radiation traveling at light speed. If one were pointed at Earth from across the galaxy, it could strip away the atmosphere within minutes. For a few seconds, these bursts release more energy than the Sun will produce in its entire lifetime. They are fast, silent, and nearly impossible to predict. Astronomers suspect a gamma-ray burst may have contributed to past extinction events on Earth. Cosmic violence does not always give warning, but sometimes danger is not explosive. Sometimes it is quiet and endless. Number 3. Rogue planets, worlds without suns. Not every planet belongs somewhere. Rogue planets drift through interstellar space after being ejected from their systems. No sunlight, no warmth, no day or night, just permanent darkness. Surface temperatures can fall so low that atmospheric gases freeze solid. Oceans, if they existed, become ice. Weather stops. Time feels meaningless. Standing on a rogue planet would mean looking into a sky almost completely empty. Silence without horizon. Some scientists speculate that underground oceans might exist beneath thick ice layers, potentially supporting simple life. But for the surface, survival is unlikely. Rogue planets represent cosmic loneliness at planetary scale. Yet even loneliness can be outmatched by something more unsettling: emptiness itself. Number 2. Cosmic voids, the universe's empty rooms. Between galaxy clusters lie enormous regions containing almost nothing. Cosmic voids stretch hundreds of millions of light years with very few galaxies inside. Compared to typical space, they are shockingly empty. If you existed inside one, the nearest galaxy might be unimaginably far away. The sky would appear almost blank. These voids are not dangerous in a violent sense. They are dangerous psychologically, reminders that structure in the universe is not guaranteed. They show that space is not evenly filled. It has gaps, absences, places where matter simply did not gather. And that leads to the most unsettling possibility of all. Not a place, not an object, but a future. Number 1. The Big Rip. When everything comes apart, the Big Rip is a theoretical scenario where the expansion of the universe accelerates without limit. Dark energy, the force driving expansion, could eventually overpower gravity, chemistry, and even atomic forces. First, galaxies separate, then solar systems, then planets. Eventually, molecules and atoms themselves are pulled apart. Space does not explode. It stretches until nothing can hold together. Every structure that ever existed dissolves. Not fire, not collapse, just separation. Forever increasing distance until meaning disappears. It may never happen, but the possibility forces a realization. The universe is not static. Stability is temporary. And every place we visited today, from Venus to magnetars to cosmic voids, is a reminder of that truth. The cosmos is beautiful, but it is not safe. So now the question becomes simple. Which of these places would you fear the most?